day, viewers. You are welcome to my YouTube channel once again, Achievers Consult, where science is made easy. We've been doing a series work on capacitors and capacitance. Today, we want to take a step further on the topic I titled Energy Stored in a Capacitor. We have looked at capacitors in series, capacitors in parallel, and we have also looked at combined capacitors. That means parallel and series combined. Now I want to look at energy stored in a capacitor. Energy stored in a capacitor is equivalent to the work done in charging the capacitor. So energy stored in a capacitor is given as work done equals half charge times potential difference, or half times capacitance times potential difference square raised to power 2, or half times charge square over capacitance. Any of these equations can be used depending on the term given in the question. So the term given in the question determines which of the equation we apply. So you have to learn the three equations by heart. You have to know them because you don't know the term you'll be given. So once you know these three equations by heart, or these three formulas by heart, anything you are given in the question, just sort out your parameters. Then you now know the equation to apply. Question 1. Looking at this diagram, they said the diagram above shows two capacitors, P and Q, of capacitors 2 microfarad and 4 microfarad respectively, connected to a DC source, is connected to a direct current source. The ratio of energy stored in P to Q is, so we have to calculate the ratio of energy stored in P to the ratio of energy stored in Q. This is JAM question 2001, question 23. JAM year 2001, question 23. Now let's look at it. Looking at the parameters we have, this formula we apply. Work done equals half capacitors times potential difference square. Now, first of all, we look at the work done on the P capacitor. Are you getting what I'm saying? No, we have two capacitors, P and what? Q. So first of all, calculate for P, then we calculate for Q, then we look for their ratios. Work done in the P capacitor equals half Cp times V square. Then to get that of CQV square. Now we have to look for the ratio. So we put the ratio of the work done in capacitor P over the work done of capacitors Q. Half CPV square over half CPV square. That means we have put the formula, put it in ratio form now. Are you getting what I'm saying? They say ratio. So these two formula now you put it in ratio form because of this that you have done. Then you cancel out. Half cancel half. V square cancel V square. You are left with Cp over Cq. So Cp over Cq is giving us our capacitor. P is 2 microfarad. Then our capacitors Q is 4 microfarad. So we have 2 microfarad over 4 microfarad. 2 here 1, 2 here 2. So we are left with half. Therefore, work done in P ratio, work done in Q equals 1:2. Any question about that? Is it clear? Now let's look at question 2. Question 2 says, it says calculate the energy stored in a 20 microfarad capacitor if the potential difference between the plates is 40 volts. This question is YF 2004, question 43. Solution, capacitance C equals 20 microfarad. You open the micro, which means 20 times 10 raised to the power minus 6 farad. Then potential difference, V equals 40 volts. Energy, W, we are looking for energy stored. We have to calculate the energy stored. So W equals half CV squared. Half times 20 times 10 raised to power minus 6 times 40 squared. When you work it out, you have 1.6 times 10 raised to power minus 2 joules. You know energy is in joules. So that's why we have joules here.